while we go live here, I'll need to very briefly make sure we also go live on YouTube. We have some of the audience that's only here. Great. So why don't we get started? No, let's not get started. Let me first find out how we can get everything started here. But we can introduce you already. So here's my friend Zach, and now we are live. Okay, wonderful. Zach, tell us a little bit who you are, what you're doing, and how you get here.
All right. I'm Zach Pitko. I am a computational neuroscientist like Conrad. And I got here by loving science. I am a faculty member at Baylor College of Medicine and Rice University. And that's true for 2 more weeks. And after that, I will be faculty at Carnegie Mellon, which is happening very, very soon. I'm like packing all my stuff with boxes and things like that. So catching me at the end of a decade in a medical school. I was always really interested in science very broadly. So I studied physics and math and chemistry and biology. And I did that sort of from the beginning. And then I remember seeing a cool talk by Bill Bialek showing that you could use physics to understand the brain. And I was like, oh, you can do that. That's what I want to do. So I started doing that. And since then, it's been kind of a random walk in exactly how to do that. Going into now these days more machine learning and statistics, and now cognitive science and connectomics, just wherever things seem fun. My background, I went to college at Princeton. I was a physics undergrad major, and then I took a year off and went traveling around the world, which was awesome.
That's
I highly
so cool.
recommend it.
Where did you go?
Worked for 6 months. I went to Japan, Australia, Indonesia, Thailand, Uzbekistan, and India. And
favorite food?
I have to say Indian food was unbelievable. I gained a lot of weight in India.
Nice.
Although Indonesian food was really good, and I ate for a nickel for a whole meal. That was pretty wild.
Wow. Okay, cool. So you took a year off, and
then I went to grad school.
Undergraduate.
And
how did you get into graduate school?
I applied to a few places, and I picked. I was lucky. I got good offers, and I picked a place that I thought had a lot of flexibility for me, because I wasn't really sure what I wanted to do. I at that point I hadn't really committed to brains yet. I still wanted to leave my options open.
Let me understand your application process. Because I'm sure we have people in the audience who are really interested in that. So you come out of your year traveling the world. How did you
I actually applied before that. I applied and I deferred. So I applied in my last year of undergrad for grad schools, and then the first thing, I guess the regular time. But then I said I was going to defer because I was going to go travel.
So let me understand how that worked for you. So there's 2 paths. Now you can apply to a program, or you can apply to a professor and then to the program. Did you apply to a professor primarily, or to a program? How did you get?
No, I applied to programs, but I got in touch with professors, and I met with professors when I went and visited a couple places. I remember having some interesting conversations. There were a couple people that I actually reached out to professors and didn't apply to the program, although I liked the professor's work. I thought that there just wasn't enough other possibilities there for me.
So I presume there's going to be lots of people applying to the same programs. Why do you think they chose you, crazy person? For everyone to know, like Zach and me, we are long-term friends. I'm just getting him to share a little bit where he's coming from.
I met Conrad on an airplane. Do you remember this?
We
first met on an airplane. You were reading the textbook by Norvig, like AI, and I was sitting like I sat next to you, and we just that was how we met.
Yeah. That now I remember.
And so yeah, and then I saw you give a job talk at some point.
But how do you think your application stood out?
So I had good grades, and I had done research. I think that was really an important thing at the time. I think it's even more important now. But I had done some projects in a variety of different contexts, and I was pretty well rounded. So I had a lot of broad interests, and I was a very enthusiastic person. So when I would reach out to people, I would learn about what they were doing. And I think that this is actually really important. And I want to mention this as like for all the students who are thinking about applying. Conrad, I'm sure you get a lot of emails from people interested in your work, but many of the emails don't say a thing about your work. They're like, I see that you do, and then there's a fill in the blank and it says like deep learning or whatever the other like, and that's just not going to get you anywhere. You have to, if you're going to contact somebody, and this is what I think I did too when I was reaching out to people, read what they do and say, this is what I like, and this is what I find interesting in your work, and this is how I might, imagine working with you. Even though you're like naive in the field, demonstrating that you have some engagement with the person's actual activities is really critical, and it makes such a difference compared to just like a form letter where you can even see that the color of the name is pasted in is different, right? Like sometimes that just shows up in the email.
And maybe let's briefly put a pin on that. Like, so what you did then is you were a physicist who wanted to understand brains. So you were kind of very specialized, not on the grand scale. Like there's basically, of all the professors in the world, there probably would have been no more than maybe 20 where you would have wanted to work, because you wanted like physics.
Well, okay, but at the time I didn't know that I wanted specifically to work on brains. I had already done a bunch of different things, and like I contacted somebody who was doing like protein evolution. I contacted somebody who was doing pattern formation in different chemical systems. Like I was very broad, and that's why I didn't like, I picked some place that there would be a lot of opportunity. So but then like all those things were interesting to me.
No, like it was like if you did pattern formation, I have no doubt it was like physics and pattern formation. Like there was like,
yeah, absolutely.
We're willing to kind of like cover a weird space. And if you're a professor doing physics and pattern recognition, you're probably not getting millions of applications, because that's just a non-standard combination, I guess.
That's right.
And the reason why I'm asking you this is like, I think there is this general thing that people underappreciate, that if you kind of are not in a niche with everyone else, then your life is easier. If you're in a niche where there's 100 people doing the same thing, like I'm sure you get lots of applications. I'm a computer scientist. I'm a really good computer scientist, and I want to do deep learning. Can I do deep learning in your field, in your lab? That's kind of a niche that's covered by lots of people. Whereas if you'd be, oh, I work on Catholic theory and I want to make a link to deep learning, that would be a very small number of applicants in that area. And so right. I think that not like if you're more specialized, there's far fewer places that you can apply to, but any one of them, you have much, much, much higher probability of actually making it, I think.
That's true. And the other thing that I'll mention here is that you can, like, there are a lot of people who have interesting, like a lot of people that you might apply to are doing really interesting work. And you don't have to talk about everything that you're interested in. So like the part that you're sharing with a potential mentor can be the part that you think they would be interested in. But you might apply to somebody else who's also interested in, a completely different thing. And so it's like you can cover a bunch of niche fields, because I'm contacting somebody who does Catholic theory and deep learning. So I'm going to emphasize the part of that I find interesting, and the part of my background that is going to be relevant. Now, there's a cost to that, right? The cost is that now you have to tailor, you have to think about stuff. You actually have to tailor what you're writing about, and you have to read the target, the web pages or the papers of the people that you're applying to. And that's time consuming, but the hit rate is going to be much higher. And so overall, it's going to be, I think, a major advantage to you.
So how many places did you apply to?
I applied to 4.
Okay, you applied to 4, which means that you will have had the time to do really targeted applications, not like an NR4. You can like be very precise why you want to be there.
Yeah.
So hold on. Okay, now you did your PhD and you did like some really interesting combination of physics and neuroscience to it. You then did a postdoc, if I remembered right. No, do I misremember?
I did 2 postdocs.
You did 2 postdocs. Tell us how did you convince those people to hire you, given that you were like a really non-standard student, I think.
So, at this point, I kind of had a sense of who I thought was doing interesting work. And so the hope would be that I could, convey to them that what I'm doing is relevant. Like there's an overlap of interests. So there wasn't a ton of people that I would want to apply to, but, I did reach out to some number of people and read about what they're doing, and I proposed a few different things and gave a talk. That's the way that you do it with the postdoc application. You go, you give a talk, you say, this is my PhD research. Some of those talks went well, some of those talks went not as well. You get practice by doing it. You got to practice talking about things, and that is so helpful in even shaping your own thoughts about what you've done.
Did you have friends invite you? This is something that I often arrange for my students, to like give a talk, not at a lab where they want to work, but at another lab, just so they can practice this, like, hey, here's my like talk with which I'm applying.
I didn't do that. No, I just gave talks that were like the application talks. I mean, maybe I gave a couple talks at like 1 or 2 as a student, and so there was a little bit of practice. And then you prepare for your I think I did my PhD defense, and then I stayed on in the lab as a postdoc for a little bit after that, like a mini postdoc, and that gave me. So I already had my PhD defense as a prepared talk, so I could give that talk. And so if you're applying as a PhD student who hasn't yet defended, then you don't have that advantage. But then, you're just going a little bit faster. I took the slow road in general.
So how many places did you then apply to for postdocs? Sorry for asking you for all those details, but it's kind of like, I want people to kind of see the experience that others go through for that.
Yeah. I guess another like maybe 5 different places, 5 or 6. Trying to remember some of the details. I probably have some of the emails. I remember applying to like one place with some really wacky idea, and the initial email was like, hey, I'm interested, I'm graduating, and they're like, oh, that sounds really great. And then I said, one thing that I think would be a cool overlap between what you're doing and what I'm doing is that I would like to make a second thumb, like a prosthetic thumb that I could learn about how to make it work. And as somebody who would use it and also program it up, I would have a greater insight. And they're like, yeah, we don't have funds for that. Sorry. And that was the end of that. So that was too much of a risk.
No, do I misremember that?
Yeah.
So you were ahead of your
time. That was like, oh my God, who is this guy? I would never recommend doing that.
Cool. So and then you became professor. How did that step work?
So the professor thing was, it's hard to get a professor job. The biggest attrition rate in academia is between postdoc and faculty. And so I applied I had very few publications when I started, when I went on the job market. I had just 1, actually, maybe 2 but in terms of like first author publications, I only had 1. And another one was getting there, but wasn't really there. And I only got 1 callback. So I think I sent applications to like 30 places, and I got 1 interview, and I got that job. but that job didn't have the resources that I needed to actually even hire like a postdoc for 2 years, like the startup funds are. And so I debated a lot about it, because now I'm thinking, oh my goodness, am I gonna, like, is this my one chance? If I turn this down, am I never going to get a faculty position? But I got a lot of advice from people, and in the end, it was like, all right, well, if this doesn't allow you to do what you want to do, then then it wouldn't be a good job for you anyway. So I waited another year and I applied, and I got multiple interviews and multiple offers, and so it made a big difference that 1 year. But it was good practice.
Nice.
To do it that first year. And it was so stressful. Oh my God, it's so stressful.
Everyone is so stressed in the job market. I'm with you. This is great. This is so now everyone got to know you a little bit. Why don't we start diving into the questions?
All right. I also am curious, Conrad, I mean, you could share a similar kind of story. I don't know if you want to do that now, but I'm curious about your own trajectory, and if there are some different lessons that you can share compared to what I just shared.
Yeah, I mean, like in pieces, it's different, but in a lot of places, it's very similar. Also, I did a physics undergraduate. I wanted to do biology. The people in Zurich, in Germany, said, no, you can't do biology because you're a real physicist. And I was part of this German program that brings together professors and students called Studienstiftung. And I basically met a professor in that summer, just after the Germans told me I couldn't do physics and biology.
This is what stage in your career? You was a PhD student or
during an undergraduate, 2 years.
Okay.
But so I was like, the guys don't let me do physics and biology, and the professor from Zurich, Peter Koenig, who was our lecturer for the summer school, was like, actually, we view that differently in Zurich. Why don't you come to Zurich? And so 2 months later, I was a student in Zurich and graduated from Zurich and moved on right from undergraduate to postdoc in the same lab. That's kind of relatively frequent because in Germany, or Switzerland, you do some research towards the end of your undergraduate degree. It's kind of enough to learn that it's fun doing research with someone. It's not enough to really learn all the things. So it felt very natural to stay on for a PhD. Then a couple of years later, I wanted to move on to a postdoc. I applied to exactly one lab, Daniel Walpert's lab. Why? Because my friend said it's kind of the most exciting lab at that point of time. I gave one talk there. I got accepted. About a year later, I got to know my now wife, Joanna Marinescu. And, she said, well, I have a PhD piece at Harvard lined up. And so I applied to one lab at Cambridge, Massachusetts, at MIT, and Josh Tenbaum. And I got accepted there. Now, let's be clear. My application to Daniel Walpert was very Daniel Walpert specific. It was like I had read like 20 papers of his, and I basically proposed, Daniel, this is how I think it would be great to do an experiment together to test that. And when I then contacted later Josh Tenenbaum, I was like, Josh, like I've been doing this with Daniel Walpert, and this is exactly how I think I need your kind of way of thinking about cognitive science to do the next step in that direction. And this is how I feel I fit into your lab. So my applications have always been basically single lab applications. They were like super over-engineered. It was like, this is exactly why you and only you can meaningfully be my next supervisor. And that in all those cases led to those offers, and that's kind of look, it's like there's people who are like naturally the best at what they do, because they work longer and are just more brilliant. And then there's people like me who do things that no one else does. And if you're the applicant that is different from all other applicants, you don't need to just be generically better. You just need to be the right next hire for Daniel Walpert or the right next hire for Josh Tenbaum. So I strongly believe in these like over targeted things instead of like I'm just generally like great. And that's what the same thing is what I see in people applying to my lab. If someone's just like, here, like you're doing deep learning, so please hire me. I want to do deep learning. That's not very exciting to me. Whereas someone's like, hey, I read this absolutely obscure paper that you put out like that preprint you put out last year, and this is like what I really want to do. And it requires this weird combination of things that like I have because I'm like totally into that. Then I get very excited. And because otherwise,
So Conrad, I have a question for you. So how do you balance your self-advocacy against the request for time and effort from them? Like you're saying, I think you're the best and I need your help, but I'm going to be able to help you too. Like, how do you think about making that both sides work?
yeah, so here's the game that I like to play in my mind, which is I think if you can predict the next paper of a professor and clarify that you're the person to write it and send them a 4-liner at most that explains why that is the coolest next project and why you have the skills to write it, they are very, very likely to offer you the job. Why? Because that's the only way how they can know that you actually care about that stuff. You know? Like it takes a lot of thinking but to kind of get at what the next paper is. And indeed, like the paper that I wrote with kind of Daniel Walpert, the first paper was pretty much what I proposed when I contacted him. Now, I proposed kind of the second paper because I didn't know the first paper hadn't already been written, but but I think no, because in that sense, like you doing something for them is the same as them doing something for you. It's not just that you want them to hire you. It's like, here's the next thing that obviously you will want to write because you just wrote this paper. And like, it's clear that this is the way forward, but that forces you to focus on that area because not everyone is as brilliant as you that they can propose like 10 targeted projects, one in like pattern completion and one in neuroscience. But you can kind of you can focus on a smaller area and say like, look, I want to do computational neuroscience, and those are like, for this professor, based on what they've done before, this is kind of roughly the right direction.
We lost your video there.
Okay, yeah. Now it's back. Okay, wonderful.
So what happens if you're like still exploring and you don't really know, like you don't know enough to anticipate what a senior experienced professor is going to do next so that you can like write the paper or the abstract before it's even like a zygote of an idea, and you're exploring?
Yes, that's no, there's multiple ways of exploring. There's one way where you like do lots of things in parallel, but there's another way where you sequentially go deep. And I think the sequentially going deep is making things easier than doing all of than doing like a lot of them at the same time. I like kind of in my scientific career, I find that I like deeply fall in love with topics sequentially. And then I'm like really like I really read all the papers on causality, and it's all about causality, and I annoy everyone on Twitter about causality, and then is the next thing. And I think kind of like this, like embracing the geeking out of something, you know, like it makes you stronger. It's so I encourage everyone to take that one professor, even if you don't know, no, like you might be wrong, but that doesn't prevent you from like geeking out. And like it's a working hypothesis. Once you work with that person, maybe you'll work on something else in the end. So I don't think it in itself is much of a problem.
So I see
So
there's a couple questions on here that maybe we
yes,
want to
I think
address.
let's go through them, and I wanna for the moment table Suha's question. It's the most upvoted. It's very important, but let's maybe directly, based on the discussion that we have, start talking about. This is a question by Fangnon Diodone, who asks, how do you get a PhD or internship opportunity? And that's certainly something that a lot of our students will ask themselves. How do you get a PhD or an internship opportunity?
There's so you're going to have to reach out to, well, first of all, it depends on where you're coming from, right? Like what kind of preparation do you have? You're going to need to explain to yourself why you think your preparation is going to be to lead you to success in this program, right? Whatever the thing is that you're going to want to do. And it doesn't mean that you know how to do the thing now. That's why you're going to get a PhD, but that your preparation is somehow appropriate, and that you have the mindset that you really you want to dig into something and be passionate about it, because you're going to spend a lot of time going deep, as Conrad is talking about, right? That's like what a PhD is all about. It's about like going really deep. So you have to convey to yourself that that's what you want to do, and then you have to convey it to other people. So you're going to end up writing a cover letter and like or a statement of purpose, which explains why you want to do this thing, why you want to dedicate 5 years of your life or more or less in a few cases to this particular niche topic, why you think that's going to be valuable. And so then you want to look at the different programs that there are that meet your needs. Like, what are the things that you want to do? How can you have a program that is the most supportive for what you want to do? And it definitely helps to be able to flag in your PhD applications why you're appropriate to have to be advised by a given professor. So when you write your proposal, you're going to say, well, here's the stuff that I do. This is what your school is really, good at. And here are faculty that I would fit in their lab really well. I'm aligned with this. And then when the application goes through the committee, they'll read through your statement of purpose, and they'll see like, you mentioned this person and that person. And if your qualifications are above the bar that they, the starting bar, then they may bring your application to the attention of that professor.
And there's an interesting detail that I wanted to just briefly interject with. So the distribution of applications per professor is very, very, very uneven. So there are some professors that are just super famous, say those that wrote a popular book, or those that for some reason are just like super, super popular. And like at UPenn, think Angela Duckworth or think Danny Bassett, both of which recently wrote wonderful books. But if you apply for those labs, and like, of course, you're most likely to recognize their names. And a lot of people feel attracted to those labs. But guess what? Like a professor can only like sponsor a certain number of students. In most programs, kind of like one. So if you're the third best student applying to insert super famous lab here, no one will even be thinking about you, because you're just like one of the 200 students applying to the same professor. So what you want to do is rather target like the interesting professors that not everyone else knows about, because it's like very generic. It like shows something like not very exciting about you if you're like the 500th student who like wants to work with the same professor. Whereas if you're like, well, look, actually, my topics are physics and pattern generation, and here's the one professor in the world that I really want to work with, people are like, oh, we almost never get an application for pattern recognition with physics kind of people. Let's ask that professor how good that student is. So that way you kind of halfway get into the door already. So, and that I think is very important. And then you need to write something that like impresses that professor in your application, which again just makes the point, like you want to be specialized and everyone's trying to be non-specialized. Like I get so many emails, you have no idea. My name is X, I study Y, my GPA is Z, I'm the 17th best student in my program. Can I do deep learning in your lab? Like no, like kind of that's the generic application. I don't feel that you're excited about something.
I've had, so one of the like, I had an application from somebody who wanted to be a research tech for a year with me. This person had read multiple papers of mine and had identified ways to connect them. It was like, yeah, we need to bring this person on. Like, I don't know how, but we have to do it because they were already working really hard on this and they were being creative. I think not everybody's going to be able to do that because you don't have the background, but you can convey the passion and interest and specificity.
But in parts, the reason why people can't do it is because they apply to 300 labs. Now, if you only apply to 5 labs or 10 labs, of course you can read 5 papers by each of them, like, or at least a good number of them. So going into depth, nodding out on someone's paper, and then trying to really work those papers into your applications is super helpful.
Yeah, it's a risk, right? It's definitely like but it's a risk both ways. And so this might give you better odds to do it the way that Conrad is suggesting.
So briefly, Timer Crayon asks, how do you find how popular a professor is? Famous authors is obvious, but also like you just go to their Google Scholar page. If they get cited 1,000 times a year, then they will be very popular. If they get cited 10 times a year, then no one cares about them. So you want to kind of target people maybe that are cited between 100 and 1,000, or maybe at most a few thousand times a year. But the people that
Another
get
way
cited
that you can
do have a lot of applicants, all of them.
It's tricky because you also want to make sure that you're contacting people who will match you both like intellectually, but also be supportive. And it can be a little unclear exactly how to do that. Like you can watch videos of people and get a little bit of a sense of their personality. And that can be helpful because now these days, people give talks. It's on YouTube. But a lot of the stuff that you'd like to know about a professor is not something that you will see on any page. You need to talk to people. So if you get an interview and if you get to go and visit, you want to talk to the members of the lab that this faculty person has worked with and get a sense of who they are, not from what they're saying, but from what other people feel about them.
Yes, some professors are really toxic. No one should ever choose a lab before talking at depth with the students from the lab. Like seriously, just don't talk with the students. It's absolutely essential. So why don't we like go a little in order of popularity? So here we have a question by Suhas Adiraju, who asked, how should one navigate deciding between academics and industry? If research is your passion, but you don't know where you should be, how do you decide? Do you decide if you should be in industry versus academia?
Well, how niche do you want your thing? Do you want to go? I think it's a really good question, and there are a lot of industry things that have a lot of overlap. But one defining feature of academia is the freedom that you have. So if you are in industry, you are expected to make a return on the investment in you, and that means products. That means like whether it's long-term or short-term. And so the work that you're going to do is going to be more targeted to the applications that are going to make money, that will be able to pay you.
But what about in deep learning? Say there's Google DeepMind, and then there's Microsoft Research. There's a range of places that kind of let you write papers. Isn't it a little more similar then?
It's true. Those are really, I mean, those are very hard jobs to get, the jobs that are really free. And if you go into industry, you may at some point be able to transition into one of those free research jobs, but that's not usually the entry. And if you're going to get a research heavy job that allows you to be free in that way, you probably already have a PhD. Not always, but probably. So you can always switch into industry once you have a PhD, or if you at any point, like Conrad, you could go into industry now if you wanted as well.
As could you.
As could I. And so I think it is a lot about the topic, but you should talk to people who've had experience in both. And there's going to be a range of experiences. Like, you're going to have a startup culture is going to be different than a big company. And even within any given company, there's going to be lots of different sectors. Like, are you working on something which is very closely tied to a particular client's needs? And so you're doing like application or data munging or something? Or are you working on building a back end for some bigger term goal? Like, there's lots of different aspects of industry. And, I think it's, for a while there was a huge rush of people to move to industry, but my understanding is that it's tougher now. The jobs are a little more contracted. And in academia as well, you still have places like faculty who will be much more like micromanaging, and others that are more like just liberated and like liberating, let you go. And that's something that you want to talk to your potential mentor about. You say, like, what kind of mentor are you? And what you want to think about for yourself, what kind of student are you? You can have something where you might be the kind of person who wants to have frequent interactions with somebody, or you might want to be somebody who's just left to your own devices for a month and come back with like some interesting results. You want to be honest with yourself about that, and honest with your faculty mentor about that, or your boss, and to figure out what you think is going to work best for you.
So I wanted to just push back a little bit on the freedom. Like, there's multiple dimensions of freedom here. In academia, we are really free to choose what questions we ask. But for example, we aren't so free to choose which city we want to live at. Like, we're very specialized people in academia. So that means that maybe in any given year, there's only 3 universities that have quite the right job for us. So, and not all of them will want us. So,
as faculty members, you mean, for like the faculty market?
Yeah, exactly. So I don't think it's generally fair to just say it's more freedom. It's a different kind of freedom. Like, you're free to choose your topics. You get paid significantly less. And this is something I tell to everyone. Like, academia, if you love asking questions, is your own questions, is really wonderful. But you're paying for that with lack of like personal freedom and lack of income. And therefore, also as a corollary of that, if you're staying in academia, what you do must be awesome. If it's not awesome, then you should be in industry and at least make money and have personal freedom. It must be like exciting and cool. And if
to you personally,
and otherwise you should probably not be in academia. Great, cool. We have lots of questions, and now we only have 20 minutes or so left. So I want to like move us a little through that set of questions.
Great.
General advice for people coming from interest in brain to computational neuroscience. I hear that question many, many times. And navigating finding positions that maybe incorporate both. How do you get into comp neuro if you like start being like neuro?
Yeah. Linear algebra. You gotta start with linear algebra.
Yes.
It's
but
adding and subtracting. It's the version of adding and subtracting when you have more, and multiplying and dividing when you have more than one number at a time. And in the brain, you have more than one number at a time.
No, Zach, what you say is skill skill training, like you want to become good at comp neuro. It's not so, but with that, I think comes like, yes, you need to up your skills, but the other one is also you need to choose a realistic path. So if you're an experimentalist and haven't done anything computational, it's unlikely that if you apply to a lab that primarily builds algorithms or does math, that they will want to hire you. Like you have like some bio skills, but you aren't quite ready for that. So the paths that I see is it's somewhat difficult if you start from bio going to computation. And then if you do, then it's usually kind of step by step, where you like take an in-between thing where you're maybe the person doing most of the data analysis in an otherwise experimental lab. You up your skills until you're kind of ready to be postdoc in a more computational lab. I mean, I don't know.
I totally agree with that, Conrad.
Do you hire people like straight out of a biolab that don't have evidence for computational work?
No, absolutely not.
The same here. And there's a lot of people who want to move in that direction, but there is this, you need to be ready for that transition.
Yeah, and I agree that it is skills. Like a lot of these things are like, it's not just that you know how, like, the rules of math, it's that they become fluent. You become fluent in it. It's like you're able to like do these things, riding a bike, and like you don't have to ponder through and prove a new thing because you already have experience. So you need to gain experience. That's where the skills come from. Now I totally agree with Conrad what you said about finding a lab that would be like a quantitative experimental lab. That would be a bridging lab, some place that does experiments but also does good quantitative analysis. So then you get familiar, you use your skills from the past, you use them in the interest of developing a new skill, which is going to lead you in the direction that you want to go. And that kind of multi-hop thing is useful, not just going from brains to neuroscience, but from any point A to point B, right? Like,
yeah.
There's a lot of cases where you want to be able to, you need some intermediate steps, and you have your eye on the goal over there, or maybe you don't. Maybe you just like the next step in this direction, and then you'll change your direction after that. So you want to be open to different opportunities. But if you have a goal that you want to find a trajectory, a set of hops that will get you there.
At least for me in my life, it's most times I kind of have a North Star, kind of something that I believe I want to learn. And then I get there by writing papers, and like by the fact that I write papers helps me learn. I think just like I'm moving along that path, and like the fact that I need to write down what I'm learning kind of like makes the learning experience only better. Cool. Let's go to the next question. This is a question by Leia Luo, and by the way, thanks for everyone for the questions. It's really, there's no bad questions. And the questions is why we're here. That's why we do office hours. It's a question by Leia Luo, who asked, if you've been rejected from multiple places before, is there anything you suggest to do?
That's a great question. And, everybody is facing rejection in a variety of ways. But Conrad, do you want to start?
Let's be a little realistic. Like the world does discriminate on all kinds of axes. Like your grades, they do somewhat matter. The university where you graduated does somewhat matter. The person who graduated 4.0 GPA out of like famous university will have an easier job making their way into PhD labs than someone who maybe comes from a small and far away place. That is part of reality. It's not a good part, but it's real. So if it's difficult to kind of get into the right positions, like I think Zach's point that you want to have a North Star and move that direction is one important part. Like what I know, like I started in Heidelberg, a small German university, went to Zurich, went to London, went to MIT. Like there's a certain trajectory. I don't think MIT would have accepted me if I applied there as an undergraduate. No way. I had a lot of C's in my degrees, and so I think it's about seeing where am I, what's like the range of realistic places that I can apply to, but then also go all in on targeting. So 300 poorly or like 100 poorly optimized applications have lower cumulative probability than finding like a niche where you really read a lot of papers and can really target and understand what's useful for the professors and what they're looking for. And that, I mean, that would be my advice. But yes, it's like getting into a great lab is difficult. Like let's not sugarcoat it. It's a lot of people want to do a PhD, in particular, say in deep learning, and it's very difficult, therefore, to get those applications. In fact, if you want to do deep learning, applying for like everyone's applying to like the handful of computer vision labs, but they now all want to do theory. So kind of there's a real mismatch of them kind of getting like lots of applications of people who want to do convnets, but like convnets are no longer a thing, and or like they do vision transfer. Everyone now wants to do vision transformers. Like there are these places where the world has too many applicants in some areas and too few in others. But if you say get into a lab doing databases, maybe they're like right at that place where they want to use transformers to like build a new generation of databases or programming languages. So kind of finding places where you have a specialization that others don't have, and you want to go away from the kind of generic profile that so many people have.
Yeah, I mean, I think, Conrad, you're suggesting that we look for needs. Where is there a need that's unmet? And if you can find yourself filling that need, then that's a more likely success route for you. But
yeah,
the question is, how do you find those needs? How do you figure that out? And
it can give you a generic need. So biology is hiring lots of people. They have this acute problem that everywhere where biology is done, data sets are getting big and questions are becoming computational. So at some level, the fact that you're at Neuromatch is already great, like at least if you're into biology, because basically biology has trouble filling people with a skill set that kind of allows them to meaningfully deal with data. And that's going to take a long time until that is saturated. So that's also for people wanting to do deep learning. Like there's a good number of labs that need to do deep learning in biology. These labs have a much harder time hiring people than people who've been doing computer vision for 10 years or 20 years. So yeah, the need analysis is important, and you should talk with people. Like which professors get too many applications, which professors get too few, and I know professors who get too few and professors who get too many. Great, let's take the next one. This is a question by Tugoldur Geralma, who ask, in your opinion, which universities labs are doing the most interesting research in deep learning, computational neuroscience, or AGI? I'm not going to answer the AGI question. I don't think it's a thing. But why don't we talk about comp neuro?
Really? Oh, maybe we have some room for discussion here.
But we're not talking science. Let's no. We're just doing office hours. Who's doing great research in okay, you go ahead with AGI. Who's doing great research on AGI?
No, I'm not going to go there now. It's ask me again in 5 years. I mean, there are some concentrations of great work in lots of places around the country. You know, I'm deeply involved with a bunch of people at Columbia, both because I was a postdoc there, but also because we now just got an NSF institute that is established. It's a multi-institutional institute that's dedicated to neuro AI, and so there's already a good collection of people, both in computer science and in computational neuroscience, that are kind of coming together to form something there. And it's not just at Columbia, but at some other universities around. Harvard just announced $500 million, the Kempner Institute, which is going to be in neuro AI. So that's an interesting confluence. And Yale has the Wusai Institute, again, a big resource allocation to neuro AI. The Gatsby in London has been a leader in this for a long time. And then there's places like Toronto and Montreal who are powerhouses in these domains. And then there's smaller pockets.
Stanford is probably the biggest group in America at the moment.
Stanford is okay. Yeah, they have huge power there.
They have. I mean, they have McClelland, who was doing it before it was a thing, and
true. He was started the whole thing, right?
And they have and they have a lot of great people at Stanford.
Yeah, they have fantastic people.
But yeah, most large universities do interesting things, and then of course at industry, not like there's Google Brain, Google DeepMind. What are the other? Like, there's a few great people at Microsoft Research. I'm sure I'm missing out on a lot of them. But yeah, lots of good places. How to answer for you?
UPenn. UPenn has some very strong people.
Amazing people at UPenn. How to find out? Start reading papers, because you're not looking for people doing good deep learning or AGI or comp neuro. You will in the end be looking for people who do something much more narrow, like the physics of pattern generation. Like I like this as an example because it's like sufficiently narrow, like, or it could be physics ways of understanding deep learning systems. Wonderful question, because it's like narrow enough that you can really understand the literature. Whereas if you say deep learning, like, hello, there's like 100,000 people in that area. Like, you can't have any overview.
That's like science. I want to find somebody who does science.
Cool. So here's a question by Zeal Shah, who asks, any tips for an undergrad thinking to pursue PhD in the future? Tips in terms of how to get more involved and what opportunities look out for? And Ekaterina says journal clubs. And
excellent.
I'm totally with journal clubs. There's more, of course. Not like, try and do an internship somewhere. Try and nod out on a small part of the field. Try and write a paper yourself already. Any other hints? I'm not sure. Maybe those are all that I have.
There's some great online seminar series that you can learn a lot of stuff from. Like Worldwide Neuro has every Friday there's what's the name? I guess it's just Worldwide Neuro. If you check them out, they have good seminars and discussions every Friday. Neuromatch conference. There's a lot of conferences where you can learn about stuff that's online and available. And this is one of the good things in post-pandemic. Am I frozen or is it Conrad?
No, you're good. That's probably just the screen.
Yeah, just cool. Frozen screen.
Let me ask Roland Herema's question. Are we at the peak of people leaving academia, do you think, or is the trend pretty much ongoing? Also, would be interested to hear who is intending to stay. Okay, I'll do a poll. Why don't you start? Oh, no, it's me. Why don't you start?
A peak of people leaving academia. I mean, I don't have any view on that. I think it's an ebb and a flow, and I can't tell the trend at the moment.
And in the end, I don't think anything is really changing there. Like, every year we train a certain number of PhD students. That number isn't overly changing. Every year we make a certain number of professors. That number isn't changing much, which probably suggests that the number of people leaving is roughly the same. People that go to industry from my lab tend to do data science work. I'm sure it looks very similar for yours. Most of them stay in academia.
One interesting thing about the equilibrium there, about things staying mostly the same, it means that on average, over the whole of academia, one professor trains one replacement, which is not a very good overall turnover rate. Now, there's certain labs where faculty will train many replacements, and other labs where there are no replacements coming from that lab. And there are some fields that are growing and some fields that are shrinking. But overall, academia is roughly staying the same, and so that's gives you a sense of how many jobs there are in academia as a whole.
Right. Cool. Let's move on to the next question. This is a good question and we should wrap up within the next 5 minutes or so. So I'll be pushing us along here a little bit. It's a question by Charan Segaran, who asks, if there's multiple different interests within one field, how would you recommend deciding which question to pursue? And I think we already answered that one, which is pursue the one that is going to be pursued by as few of the other people. No, is there anything to add to it? No, and of course the one that you're most excited about.
Yeah, exactly. You have to compromise between those two. Like you have one that you love the most and the one that you think would be the easiest to make the kind of progress you want. And that's a very personal trade-off.
Cool. Here's a question.
But I would say my statement is try for both and see what happens. And Conrad would say, well, dedicate more resources to fewer. So what's the right balance there?
Here's a question by Ekaterina Dakesamanskaya, who asks, as an international researcher, how to survive constantly reapplying for temporary positions and reforming skills at each stage. I'm an international researcher myself, and I think the answer is the situations for international people isn't necessarily different. Like if you apply for a PhD, you apply for a postdoc, maybe you apply for a second postdoc, then you apply for a professor position. For every one of them, there's opportunities for international people. Is it a little bit harder? Yes, it is, because in America, it's easier to fundraise for Americans than it is to fundraise for foreigners. That same country people bias is probably universal. The Europeans do it just as well, by the way. Next question. Here we have a question by Preti, who says, I'm a recent grad and I do not like the idea of academia, but as I'm working, I found myself building models of small neuroscience topics like ganglion cells and Hopfield networks from scratch. Do you have any advice for me to get back into the field with no formal research experience? But hold on, you don't like the field of academia.
Didn't past tense.
Oh, didn't past tense. Okay, if you
but now you like it.
Yeah, so I have a lot of friends who are professors now who first did industry or something. That's not a problem at all. I think these non-standard paths are coming up more and more, but what you do need to do is find kind of a unique area in which you can shine. And if you do, then that's great. Like the question is then, how do you set yourself up apart from the people who kind of stayed right in, who will tend to have more publications and better networking and things like that?
Yep. If you have passion and you point to the ways in which you bring something valuable, you can hopefully find your way.
Cool. Here we have a question by Zaim Hadi. Are research assistants with relatively more research experience and publications less likely to be recruited as PhDs compared to fresh undergraduates? Absolutely no. No, like if I can hire someone who has more skills for the same money as someone who has less skills, guess what? Who I'll be hiring? I think I generally assume that professors are mostly rational and that they're looking for skills. In general, people often focus on prestige in what they can optimize. If you can build skills or produce prestige, in most cases for your life, building skills will be more useful than prestige, in my opinion.
And if you're on the other side of that, if you're somebody who's fresh out of undergrad and doesn't have the skills of somebody else that you're competing with, then you have to argue that you have potential, right? That you have a trajectory that's going to take you in a direction where you'll acquire the skills quickly. And so that's going to be your edge in competing with somebody who already has more experience.
Cool. Well, now for the remaining 7 ones, given that we're technically over time, we will do a lightning round. How to choose PhD in the United States or Europe? Which one's better?
Where do you want to live?
That's the right answer. Exactly. Neither is better. It really depends on where you want to be. If you want to live in the United States, it's better to do United States. Same for Europe. you mentioned, this is a question by Liliam Norori, who asks, you mentioned one of the ways for undergrads to get involved is by starting to write our own papers. What is the step-to-step for doing it?
I mean, I guess the first step in writing is to write. And you're going to get better by, making mistakes. And so if you find something that you want to write about, whether you know how to write about it or not, you just try, and you'll take a look and you'll
blog about it. Go to NeuroMatch, find a few good friends, do a project, write a paper about it. Lots of people have done that before, or some people have done it before. It's hard, of course. Next question. This is a question by Augustina. Advices to apply to PhD abroad for international students.
I think it's similar to applying as a domestic student. You just want to have a good statement of purpose of what you want. You want to target the right program and the right people, and try to make a compelling case why you're the right person for that position. You don't want to be generic. You want to say, like, you're special and here's why. And everybody's special in some way. So you have to find a way to leverage what you're special in and how that's going to be helpful for somebody else.
Yep. How to find fellowships for people wanting to work on climate science for international investigators in particular. That's of course not my area, but what I do is like look on Twitter, kind of network, ask other people who are in climate change. There's a lot of channels now, but talking about
also get involved in Climate Match, right? Now we have Climate Match too.
Yeah,
another interesting place that you could check things out. There's going to be a good network there.
The other thing is, of course, that there's relatively few professors in climate change, and relatively many people want to work there. So when it comes to competitive situation, it's probably harder to get a position there than in other areas, but I don't know that for sure. Here's a question by Shraddha, who asks, lack of pay in academia has been alluded to a couple of times in this and in the last conversation, and wondering why there's some advocacy and effort on making pay scales more acceptable, not necessarily industry scale, the financial loss that have to pay, limits who can stay in science. Look, the world isn't the way the world should be, but it's a supply and demand thing. There's far more people who want to do PhDs than there's positions for PhDs. That is ultimately, in a big competitive world, leading to a decline of salaries of PhD students. And is it better to change that? Yes, of course we should change it, but the system is difficult to change in that regard. But people have made progress by unionizing. I think you should all unionize. Don't quote me. My university might not like that, but it's still probably, not like it's a negotiation. If you want to win the negotiation, you must find ways of breaking that supply and demand problem, and unionizing is one way of doing that. And this brings us to the last question. It's by Yvonne Roa Rodriguez. What do you think about working on academic research that you will know never will be applied? Shouldn't research be related to solving real world problems? That's a fun last one.
Yeah, that is fun. I think that people make the most impact when they love what they do. That's what's going to give you the most motivation to do things, and that's going to keep you dedicated to the thing that you're doing the longest, and ultimately will give you the most output. So I think that having, and we don't know the future. We don't know what is going to be applied. So the idea that we would know that something would never be applied, I think I would contest the premise. And so I personally advocate for people doing what they love, and going with that.
This right, exactly. Curiosity driven is the winning combination. I mean, was flying to the moon like useful for someone? Did anyone get cured by flying to the moon? No. Was it one of the coolest things mankind has ever done? Like, hell yeah. I mean, like the idea that you need applications of things. No, like much of math might never have applications. It's just still nonetheless like super, super cool. Demanding that everything has applications, I'm just not on board with that. I want to recommend to everyone to also follow your curiosity. Curiosity is valuable. And I do think that mankind wants to pay for their curiosity. Like, why do we study the brain? Because it's just so freaking unbelievably cool and exciting and something we all want to know.